if you've watched our last videos, you know that to begin finding the sine of 2 theta, or the cosine of 2 theta, we're going to start by drawing a triangle. And what's different in each of these videos is how we find out what quadrant to draw the triangle in. And so here's our third and final way we're going to take a look at how to draw the triangle. And this is going to go back and use some old things from geometry, specifically the equation of a circle, x squared plus y squared equals r squared. And so here's how this is going to work. I'm given, or actually they tell me that I'm drawing my triangle in quadrant 2. So I'm going to go ahead and just draw the triangle in, but then how I find my sides is going to be what's a little bit different. So one thing that I'm noticing is they're telling me that this point, it's going to be this point right here, is the point on a circle. I'm going to just kind of dash that in real quick so that we can see that it's kind of like the hypotenuse of that triangle is the same thing as the radius of that circle. And so I guess what would be helpful to know is what the radius of that circle is. If I can erase some of my circle marks real quick. There we go. So let's see. This 20 is going to be relevant to that. So that 20 is not the radius itself. Remember, what we had from geometry is that 20 is actually the radius squared. Okay, and so then to find the radius, I'll have to take the square root. And so the radius is the square root of 20, which is a great radius. However, I need to kind of break that down and simplify it. So using this idea, I can break that down to 2 times 10. And break 10 down to 2 times 5, and so the pairs come out, the singles stay in. And so the radius of this circle, or the hypotenuse of my triangle, is 2 times the square root of 5. So it took a little bit of work, but fine. We got the hypotenuse. It's 2 square root of 5. And remember, that's always going to be a positive value. The next thing they're going to tell me is they're going to give me another side of the triangle, but they're not giving me sine or cosine. Instead, they're going to give me a point. They're going to tell me the coordinates of that point we had talked about. And they're only going to give you one of the values, though. And so in this case, they tell you that point is located at 8, 4. Remember, the first point in a coordinate tells you to go left or right. So the left or right number is the one we don't know. The second number, the 4, tells you to go up or down. And so I have the vertical side of that triangle. The vertical side is going to be 4. Okay, so after all that work is done, now I can continue this problem the same way as we did in the previous videos. So I want to start by finding that missing side, so I'll do Pythagorean theorem. I'll just call the missing side x. So x squared plus 4 squared would have to equal the radius, or the hypotenuse squared, 2 square root of 5 squared. If you're typing that part into your calculator, make sure you use parentheses around 2 square root of 5. This then becomes x squared plus 16. My trick, if you watch the last video to square something like this, is to do the outside number times the outside number times the inside number. So 2 times 2 times 5, or 20. Did any of you know that that would be 20 without even doing the work? Remember, we already knew what that number squared was. We knew it was 20. Okay? But anyway, I mean, it would work out either way. So subtracting 16, then I get x squared is equal to 4. And so finally some good news, a nice simple answer. I get that missing side is 2. Well, actually, I should say x is 2. That missing side's not 2. That missing side is actually negative 2. Because remember, you have to manually add on positive or negative signs. If you're moving left or moving down, those sides would be negative. So finally my triangle's complete. I'm going to go ahead and find the sine of theta and the cosine of theta, and then I can apply those to the sine and cosine of 2 times theta. Or sine times 2 theta. Anyway, you guys know what I meant. So the sine is going to be the opposite, which is 4, over the hypotenuse, which is 2 square root of 5. And I had a lot of people groan in class when they saw that, because they said, well, we can't have a square root on the bottom. And they're right, but it turns out it's actually not going to matter for this problem by the time we're done with it. Cosine is going to be the adjacent side over the hypotenuse, so negative 2 over 2 square root of 5. And again, don't stress about that negative or that radical on the bottom. You're right, we can't have it there, but watch, it's not going to end up there soon enough. Okay, so all my pieces are now in place to find the sine of 2 times theta. Recall that formula, your double angle formula, was 2 times the sine of theta, which is 4 over 2 square root of 5, multiplied by the cosine of theta, which is negative 2 over 2 square root of 5. And so all of this needs to be multiplied together. If it helps, put that over 1. We're going to multiply all along the numerators. So 2 times 4 times negative 2 is negative 16. And along the bottom, once again, I have 2 square root of 5 times itself, or in other words, 2 square root of 5 squared. It's still going to be 20. It's been 20 all along. It's still going to be 20. And so see, we don't even have to care about that square root on the bottom. It's going to get rid of itself by the time we're done. That fraction can be simplified, so we will go ahead and simplify that to negative 4/5. So the sine of 2 theta is negative 4 over 5. And we'll do a similar thing with our cosine of 2 times theta. Remember, different formula though. This formula was the cosine squared. So, no, not negative 4. Sorry. Our cosine was negative 2 over 2 square root of 5. And I'll square that. And then minus the sine squared, which was 4 over 2 square root of 5 squared. So cosine squared minus sine squared. When you square a fraction, just do the top and bottom separately. So negative 2 times itself is positive 4. Be sure to use parentheses if you're using a calculator for some reason. The bottom, again, 2 square root of 5 squared. It's still 20. It's always been 20. It's still 20. My second fraction then, 4 squared is going to give me 16 on the top. And another 20 on the bottom once I square 2 square root of 5. Adding or subtracting those two fractions together gets me negative 12 over 20, which also can be simplified down to just negative 3/5. So there we go. There's our sine of 2 times theta and our cosine of 2 times theta.